pneumonia of unknown cause detected in Wuhan, China on the 31st of December 2019. Today we know that the infectious agent was a virus of the coronavirus family which was named SARS-CoV-2 that causes a respiratory disease termed COVID-19. This virus has not only received widespread media coverage, but also caught the attention of scientists who have been busy analyzing the virus, the disease it causes and how it spreads. There is already an enormous amount of information available about the virus, and that is why we thought to summarize some of the information in this video. First of all, what do we know about the virus? Coronaviruses receive their name from their appearance in electron micrographs, where the pronounced spike-like protrusions create the effect of a corona, Latin for crown. The genetic material inside the coronavirus is RNA, and the entire genome is almost 30,000 bases long, packed together with a nucleoprotein into the viral particle or virion. For the virus to replicate, however, it needs to insert its RNA into cells and hijack the cellular machinery to produce new viruses. On its surface, the virion contains three main proteins: the envelope, the hemagglutinin esterase, and the spike protein. These are embedded into a lipid bilayer. The large spike protein is responsible for the crown-like protrusions, but it also recognizes the corresponding receptors on human cells called ACE2. The protease ACE2 mediates the cleavage of the spike protein, which then releases an epitope enabling the subsequent fusion of the virus with the human cell.
Coronavirus is a newly discovered strain from the coronavirus family that causes respiratory disease. Humans have long been infected by coronavirus, as it is one of those responsible for the common cold. It is a contagious viral infection spread through inhalation or ingestion of viral droplets. As a result, coughing and sneezing and touching infected surfaces are primary sources of infection. The structure of coronavirus has multiple parts. Inside the virus lies the genetic encoding that allows the virus to hijack human cells and turn them into virus factories. A protein encapsulates the genetic material known as the viral envelope. On the surface of the viron are S and HE proteins. The structure of the 2019 novel coronavirus is a mutation. For more information on this, see the link below. The large S glycoproteins are used by the virus to gain entry to human cells. They most likely attach to angiotensin-converting enzyme 2 receptors on the cell membrane, allowing the virus entry. The exact mechanism for this is not known. Most likely, as shown here, the human cell ingests the virus in a process known as endocytosis. Once inside the cytoplasm, the endosome opens to reveal the virus's genetic material, a single-stranded RNA. The virus hijacks the cell's machinery to replicate the RNA and N proteins and uses the endoplasmic reticulum to form its M protein outer layer and the all-important S protein. After replication, the virus is carried by the Golgi bodies out of the cell in a process known as exocytosis, so that it can infect other cells. Meanwhile, the stress of viral production on the endoplasmic reticulum eventually leads to apoptosis, or cell death. It should be noted that the mechanism of action for 2019 novel coronavirus is unknown. However, scientists in China have sequenced the genome, while others have used the sequencing to visualize the structure. There is currently no cure or vaccine for the 2019 novel coronavirus, and treatment is only supportive. Therefore, preventing transmission is paramount. As an airborne virus, recommended precautions are similar to those for preventing the flu. This includes washing hands regularly with soap and water for 20 seconds, covering sneezes and coughs with the inside of the elbow, refraining from touching high-contact surfaces like railings and doorknobs. If you use tissues, throw them away immediately. Avoid close contact with people who are sick. For more info on precautions and best practices, see the list of references below. The pandemic risk of the novel coronavirus is very real. However, biology has advanced greatly in the 15 years since SARS, and so has communication between biologists and governments. China has taken monumental efforts to contain the spread of the virus. Also, some existing and experimental drugs are offering hope for treating the infection and improving outcomes. But even still, infection control habits remain paramount if humanity is to stave off a full pandemic. For further information, see the resources listed here.